Hello and welcome to another Cashmatics video. This is the third video in a series of videos concentrating on differentiation, and if you haven't seen the first two, then I highly recommend you watch those first so you know where we're at when it comes to some of the techniques which have been covered in those first two videos. Now in this video we're going to be looking at the product rule, and it is another important technique, so grab yourself some paper and a pen and get ready to make some notes. So the first question we need to ask is, when would you use the product rule? And it's quite simple. It's if you've got a function which is a product of two other functions of x in this case. So for example, if you had let's get a white pen. Okay, if you had y equals uv, and u is some function of x, and v is also some function of x, but a different one to the first one. Okay, so v is also some function of x, then dy by dx would equal u dv by dx plus v du by dx. So basically what this would mean is you write down this function and multiply it by the derivative of v, and then you write down v and multiply it by the derivative of u. And sometimes you might see it written slightly differently. You might see it written like this: u dv plus v du, and it's got some kind of symmetry to it, and a bit of, I don't know if you want to call it poetry, but it is quite easy to remember. I'm not sure if this one's going to be given to you in your particular formula book, depending on which exam board you're with. But it's quite an easy one to remember, and if you say it in your head enough times, it will stick. And out of this one and the next one we're going to be doing, which is called the quotient rule, this one's actually the easier one to remember and apply. So make a note of that, and what we'll do is we'll cover some examples, and hopefully by the end of it you'll have a better understanding of how the product rule works. So just to make things a little bit easier, what I've done is I've written the product rule there on the top right, and let's just look at our first example. And this is it. So y equals x squared sine x. So one of the functions is x squared, the other function is sine x. So the way I like to set out my working is as follows. So what I would do is I'd say, well, u is equal to x squared, so I'd write that there, and v is equal to sine x, and du, and when I write du, I mean du by dx. So you differentiate this one, so that's going to be 2x, and dv, and just like before, this means dv by dx. The derivative of sine x is cos x. So if you put a cross there, it tells you exactly what you need to write down for your final answer. So let's just write that down. We've got dy by dx, oops, let's make that a little bit neater. Dy by dx equals u dv, so x squared cos x, plus v du, so sine x times 2x. Now I tend to write the 2x first. It just makes it look a little bit neater. Oops, sine does not have two dots. There you go, sine x. And you may be asked to show that this simplifies to something, and in this case we can take out a factor of x. So let's just do that. So x, so I've got x cos x plus 2 sine x. So that's the answer for the first example. Okay, so hopefully that's made a bit of sense. It was a nice easy one to begin with, and we'll just work our way through some increasingly difficult examples, but the process is exactly the same. The only difference being you're going to have to sometimes use the chain rule, which we used, which we learnt in the last video, but overall we're just doing the same thing again and again, just with some slightly more difficult examples. So this is example number 2. Right, so in this case we've got e to the x squared and we've got sine x. So let's just say u is equal to e to the x squared and v is equal to sine x. Right, so let's work out what du is first. So du, now e to the power something just becomes e to the power something, but this something is another function of x, so I need to multiply it by the derivative of that, which is 2x. So overall I get 2x e to the x squared, and dv would be the derivative of sine x, which is cos x. So I can write down my final answer now. So u dv, so dy by dx would equal u dv, which is e to the x squared multiplied by cos x. So e to the x squared cos x plus v du, so sine x multiplied by all of this, but I'll write it in this order because it just looks a bit neater. Okay, and if you need to tidy that up, you can probably see you can take out a factor of e to the x squared and put the rest in brackets. Right, so let's go on to our third example and see what problems this might bring up. Okay, so I'm going to need a little bit more room to actually do the working here, so I'm just going to spread things out a little bit more than before. So I'm just going to write my two functions here. So my first function is e to the sine x, and my second function is x squared plus 1 all squared. Okay, so let's write down what du is. So e to the power something is just e to the power something, but I need to remember to multiply it by the derivative of sine x. So this would be cos x, well, let's just write it in the right order, e to the sine x cos x. Okay, that's a little bit neater. And dv would be, now this is something squared, something squared, like for example x squared would be, well, not x squared, that's going to confuse you a little bit. If this was say t squared, it'd become 2t. So this is something squared, it'll become 2 something. So 2 something, okay, so 2 brackets x squared plus 1 multiplied by the derivative of what's inside the brackets, which is 2x. So let's just tidy this up a bit. So this would be 4x x squared plus 1. Right, now let's just put it all together. So dy by dx would equal u dv, so e to the sine x multiplied by all of this. So e to the sine x multiplied by 4x x squared plus 1, add v du, so v multiplied by du, which would be x squared plus 1 squared multiplied by e to the sine x cos x. And again, I would most definitely tidy this up. So let's see what we can do here. We've got a e to the sine x in both terms. Okay, so we've got an e to the sine x over here and another one over here. We've also got an x squared plus 1 in both. Okay, so that's something else we could take out. So let's just take that out. So e to the sine x squared plus 1, and let's open our brackets. So here, what's missing? So we've got most of this, we're just missing a 4x, plus we're missing a cos x, and we're also missing another x squared plus 1. So cos x squared plus 1. In fact, I'd probably write the x squared plus 1 first. Okay, so that's that one there. Looks a bit complicated, but it's the same thing again and again. It's just slightly more complicated functions that we're dealing with. Right, and let's go on to our final example now. Let's have a look at what we've got here. Okay, now this one looks horrible, but it's not too bad. Okay, so let's just do what we did before. Let's write down what u is. U is equal to sine of 3x squared, and v is equal to ln of sine x. Let's deal with this one first. So du, so sine something because cos something. Okay, so it'd be cos 3x squared multiplied by the derivative of 3x squared, which is 6x. Let's write that a little bit neater. So I'd say that is 6x cos 3x squared. Okay, my x looks a bit like a u there. Let's just change that. 3x squared. And over here, dv would equal, well, ln something becomes 1 over something, so 1 over sine x multiplied by the derivative of sine x, which is cos x. Okay, so this becomes cos x over sine x. Now, if sine x over cos x is tan, cos x over sine x is 1 over tan, and 1 over tan is called cot. So I'm going to write this as cot x. Right, so let's just put it all together. So dy by dx equals u dv, so cot x multiplied by sine 3x squared plus v du, so ln sine x multiplied by 6x cos 3x squared. So I would probably write that as 6x ln sine x cos 3x squared. Okay, you don't have to write it in that order. I just like to write my x's before the other functions. And let's see if there's anything we can do with that. No, I'd probably leave it like that unless the question wanted me to write it in a different form, just to sort of show off some trig skills. But that's essentially it. So you started off with a nice easy example just to show you how the process works, and then I moved on to some other examples where you were using a bit of a chain rule to actually differentiate the function. So, you know, don't think when you're using the product rule it's just the product rule you're using. Okay, it's a combination of the product rule and the chain rule you might have to use. And, you know, sometimes you might have to combine various different differentiation techniques in the same question. Okay, so I hope that's helped. You know, go through the video again if you need to hammer some of them points home, and then try some questions and see how you get on. And that's it for now. So the next video will be about the quotient rule. So I'll get that uploaded soon, and hopefully we can move on with our calculus. Right, see you next time.